If you want to perform atomic operations in a multi-threaded application on, for example, an integer to increment, decrement, or add, you don't need to introduce a lock like we've just seen.
There's a handy class in system.threading that allows you to perform atomic operations for shared variables. This is suitable for multi-threaded applications. The class interlocked exposes a lot of functionality to perform atomic operations on 32-bit and 64-bit integers. Let's say that you want to increment a variable with 1 in each iteration of a parallel loop. Doing this with our previous approach would require a lock object, a lock, and the code to interact with a variable. We can simplify this and use the interlocked class. Using interlocked.increment and passing a reference to the integer that we'd like to increment with 1 will ensure that only one thread interacts with this at the same time. You could use this, for instance, to track failure or successful attempts to some interactions in your parallel operations, without even having to introduce a lock object for the shared resource. This means we have less code. You could also use decrement, and can you guess what the result would be in this given case here? I'm sure that you guessed that this will return -100. If we'd like to do something similar to what we did earlier, where we add to a totals variable when we get a result back from compute, we can also use the interlocked class. Because the interlocked class only exposes atomic operations, you won't be able to use it with a decimal. It only works with integers. This means we are going to lose a little bit of data because we have to cast the result that's coming back from compute to an integer. But for the purpose of this demonstration and this exercise, I'm okay with that. Interlocked.add takes a reference to the variable that you want to add a value to. After it retrieves that value, it will add the second parameter to that value and simply replace the value in the referenced integer. Really, this here is just a thread-safe version of doing totals plus is equal to result. If you do this, you can see that the result is now 4,950 and not 5,000 like we've seen earlier. This is because the decimal returned from compute had to be cast to an integer, and thus we lost some data. Although each time we run the application, it yields the same result. This means we introduced a thread-safe approach of adding two integers. In my opinion, this is a much cleaner approach, although it does only work with integers, so that's really important to keep in mind. You could also use the interlocked class for niche and specific situations. There's an interlocked AND as well as interlocked OR, which allows for you to do bitwise operations. You also have interlocked.exchange of t, which is the only atomic operation that allows you to work with a reference type. This generic method allows you to exchange the value in a shared reference type and guarantee that no one else is exchanging at the same time. It will also return the original value. There's a non-generic version of the exchange method as well. This you can use for integers and doubles. I suggest that you experiment with the interlock.exchange method. An example use case that you can try and implement is to use it as a gatekeeper instead of using a normal lock object. Think of having an integer that represents open or closed. With the introduction of the interlocked class, you now have a cleaner approach to update and work with shared variables, with the given constraints. There are benefits of using the interlocked class and the atomic operations it provides, although a lock object provides much more flexibility.
Next, let's discuss how to introduce a deadlock, which is clearly something we'd like to avoid. Understanding how it occurs will definitely make you a better developer.